Hello, class. Hello, class. I'm going to be teaching you today about how to graph other functions. Yesterday, you should have learned tangent and cotangent. I know some of you might have been confused, so I can review it one more time really quickly and see some of the worksheet problems you went over yesterday and try to see if you guys have any questions or still things you want confused about. Remember, if you get confused, you can email me, you could message me, you could tweet. But if you're still confused, you need to let me know now before it's too late. We're just moving along to more graphs, so if you're not following along, make sure you ask for help. So yesterday we talked about tangent. Tangent and cotangent are the only trig functions where its period is pi, which means every segment of pi, it repeats the same cycle. It starts at 0, 0, and the period is pi, so I always start with 0 and pi. And some of you may be confused. Remember, when I graph trig functions, if it's a period, I always also write out the halfway point. So if it's pi, the halfway point is pi over 2. You notice in tangent, remember at the halfway point, I have an asymptote, or this vertical line. So I go from 0, 0, go all the way up, and then from pi over 2, I start from the bottom, go all the way back up to pi. And this repeats over and over and over again. Okay? Cotangent's very similar. If you could look at both of them on the same, on the same screen. Instead of going 0 to infinity and then negative infinity to 0, it's reversed. Instead of starting at 0, I start at infinity. At the halfway point, I go to 0. And then all the way at the end of the period, again, it's pi, I go to negative infinity. And if I zoom out or I look back, these lines, looking at the top and the bottom, these lines are exactly the same, just sort of flipped over. Okay. So yesterday on your assignments, if I could just pull this up real quick, I can give you a couple of examples if you're confused. So for example, this tan 2x, what I'll be doing, and maybe I'll just write it over here, tan 2x. Tan 2x, you'll notice, I wish I had a blank. Here, let me just erase this real quick. So tan 2x, you remember when we do any trig function, the number out in front is the amplitude. And remember, for tangent and cotangent, it means a flatter curve and a straighter curve. Okay, so tangents normally has a period of pi, and yeah, so we're going to do the one from yesterday, tan 2x. So number 1, tan 2x. So I know my amplitude is 1, and I know I need to use this to get my period. Okay, so remember yesterday, or for this example, this is technically half x. So if my period is pi, I did pi divided by half. Okay. Or if my period is 180, if you guys like degrees, 180 over half. So you guys see here my number is 2. Okay? So my new period is going to be 180 over 2, if you like degrees, or pi over 2, if you like radians. Okay? So this is my period, and then remember 180 over 2 is 90, so the period in degrees is 90. Okay? So how do I draw that? What I'll do is I have to draw the period, which is pi over 2. And I'll draw the halfway points. Remember the halfway points for pi over 2 is pi over 4. And for tangents, remember I started 0, 0. At the halfway point, I have an asymptote, or a vertical line. So I go from 0, 0, go all the way up. And then from pi over 4, I go from the bottom back up to pi over 2. And then this repeats over and over and over again. Okay, so that's how you graph it. I know some of you said that you're confused about period. Remember, in the period, all I do is take whatever number is right here. In this case, it's 2. In this problem, it's half. In this case, it's 2. And take 180 divided by it, if you like degrees, or pi over it, if you like radians. Okay. Let's see if there's another question that you guys. I wish I could ask you guys. Sorry, I'm trying to find. Now I'm trying to find the old worksheet. Here you go. So let's just say we want to look at, I'm sure some of you want to go over the harder ones. So if you didn't get 9 and 10, maybe we could wait till I'm in class with you guys. But other than those two, I think you should be able to handle everything else. So let's go over the new graphs we're going to go over today. It's called secant and cosecant. If you remember your trig, and hopefully now it's getting more and more familiar, cosecant is 1 over sine, or sine flipped, and then secant is cosine flipped. Okay? So all I'm basically doing is taking the inverse of those functions. Okay. So the very easy way to remember it, most people forget, is I could graph a sine or cosine curve. Wherever it's a min, I will make it a max. Wherever it's a max, I'll make it a min. And those that are not maxes or mins, basically the halfway points, I'm going to make them asymptotes. Or another word for asymptotes are like those vertical lines that I drew last time. The period is also 2 pi for both cosecant and secant. Remember, the only difference is tangent, where it's pi. So this is how I'm going to draw it. So secant, or how about this? To make it easier for you, let's review how sine looks like. Okay, so here's a graph that I'm going to draw. Remember, sine's period is 2 pi. Okay. And remember, when I graph it, I'm going to need the halfway point. The halfway point to 2 pi is pi. If you remember, sine starts at 0, is 0 in the middle, and ends at 0. It rises to the amplitude, goes back to pi, and then it goes down to the amplitude, goes back to 2 pi. So if I draw it out, it looks like this. Remember, my amplitude for sine is 1, so this is 1 and this is negative 1. So that's how sine looks like. So essentially I need to graph the inverse, or the flip of this. How does that work? Everywhere I have zeros, okay, remember it's 0, pi, and 2 pi. What I'll do instead, here, let me draw pi, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 2 pi. So instead of drawing this, everywhere I have a 0, I'm going to do an asymptote instead. So you see how it's 0 at 0? You see how it's 0 at pi? And you see how, we talked about it, it's 0 at 2 pi? So I have asymptotes. And what it looks like, remember I told you where it's a min, I have a max, and where it's a max, I have a min. So you see like this little, the peak here is a max. I'm going to have a min there. And you see how it's like halfway between 0 and pi? So for secant and cosecant, and it might be helpful for sine and cosine also, I just never emphasize it, you might want to have the halfway point for those segments too. Okay, so half pi and 1.5 pi are the halfway points. Okay. And this is how you graph it. And I know it might be confusing, but just follow along. Basically, you make a U. So you see how on my sine graph, my max was 1. Now, my min is going to be 1. Okay. Do you see here on my sine graph, my minimum was 1? Okay. Now over here, my maximum is going to be 1. I'm going to move this 3 pi over 2 real quick. Or forget it. So it's going to look, the max is somewhere right here. How it looks like, essentially it looks like U's and upside down U's. So this first segment looks like this, and this bottom segment looks like this. And it repeats forever and ever. So up, down, up and down, up and down. That's cosecant. Okay. Remember, the easiest thing to do is graph the sine graph and then do the inverse. Okay. And I have vertical asymptotes at every I have vertical asymptotes at every pi. So 0, pi, 2 pi, 3 pi, 4 pi, I have vertical asymptotes everywhere. Okay? So that is that. How about secant? Whoops. How about secant? Same thing, what I'm going to do, or the easiest thing to do first, is let me draw the cosine graph. Here's my graph. Cosine has a period of 2 pi. Since I have a period of 2 pi, what I'll do is I'll write the halfway point. And if you remember, cosine starts at the amplitude and ends at the amplitude and makes this big giant U. And at the midway point, it goes to the negative amplitude. So say my amplitude is 1. I start at 1. I drop down to negative 1. And I go back up at 2 pi to positive 1. So it looks like this. And probably straighter and neater. Again, I'm doing this on a mouse. But that's how cosine looks like. Okay. So same thing, cosine, like sine and cosine, they're both waves. Secant and cosecant are both upside down U's and upside down U's. U's and upside down U's. Okay. So remember, where max is min and min's a max. So do you see here, I have a max of 1. So that means I'm going to have a minimum of negative 1. Okay. Then here I have a minimum at pi of -1. Oh, sorry. Since my max is 1 here, it's going to be my min, so 1 is going to be my min here. Here I have a min of -1, so this -1 down here, and let me draw pi and 2 pi. My min is -1, so that's going to be my new max. So I'll put a -1 here. And then at the top, at 2 pi, I reach my amplitude again, so still the same thing. I'll be back at 1 at 2 pi. But now it's a little bit different. Remember, every time I hit 0, just like on the last graph, every time I hit 0, I draw a vertical line. So do you see at the halfway point of pi, and supposed to be the halfway point between here, I hit 0. So at the halfway points, pi over 2, and 3 pi over 2, or half pi, and 1.5 pi, I'm going to have vertical lines. Okay. And now since this is supposed to be, here on cosine it's a max, here it's supposed to be a min, it's going to look like this. In this segment, it's going to look like this. And then in this segment, it's going to look like this. And then if I go on repeating over and over again, I mean this U connects, and then I have a U on the bottom. And then this U connects, and then I have a U on the bottom. So again, just like the last one, use over and over and over again. Okay. Same thing as the other one. This number out in front here changes the period. The period's normally 2 pi. And then the number out in front, this amplitude, because it's not really like, how can I say this? It's the amplitude. So for tangent, if I went back, remember tangent made it flatter and straighter. But for cosine and sine, remember it's my amplitude. So remember here, my minimum was 1. Now it's, well, here it's still 1. But if, say this was 3 secant 2x, that means this would be 3. And this would be -3. Or if my amplitude was 5, that means this is 5 and this is 5. So remember that's the amplitude. So I only have time to really just go over one. And you can practice at the end of the class. And I'll show you guys the answers so you see if you're on the right track. So secant 2x, the only thing I'm changing about secant is that I have this 2 here. So I need a new period. Let's just do, let's just stick to radians because that's what we've been doing. So the period is normally 2 pi, and I divide by the number that's out in front, which is 2, which tells me my new period is pi. Okay, so far? And I have the secant graph up here to give me a reference. Okay, so instead of saying pi and 2 pi, what I'll do, and I'll mirror the same up there, I'll make this pi, and my halfway point is pi over 2. Okay, so now that's the only thing that's changed. I'm going to copy this exact same graph, except for it's like it's squished by pi. So remember how I have in my period, I wrote the period, I wrote the halfway point, and then in between 0 and pi, in between pi and 2 pi, I had a vertical asymptote. So between 0 and pi over 2, here's my vertical line. And between pi over 2 and pi, here's my vertical line. Okay. Remember I have and I'll do a different color. Remember I hit my, in cosine it's my max, so in secant it's my min. So I'll have a min at 1, and I'll go all the way up. And then I have a max of 1 up here, so it'll look like this. And then like this. So, sorry. Looks like, I wish there was an easier, here. Let me just drag away. So I start at 1 and I go up. Here I got a U, so it looks like this. And then here I got this. So that's how the secant graph looks like, sort of squished. So if you look at this function, see how it's like more spread out? This is how it's standard, how it normally looks like. And in this one, I just sort of squeezed it, condensed it, like so. Okay, and it repeats on forever and ever. So you'll see that the real difference when I change the period, or when this number out in front is bigger than 1, it makes my graphs more condensed. So do you guys see now how period works? So just to review, you take the period, in case it's 2 pi, and I divide by this one. Okay. Hope you have, let me know if you have any questions, like email me, message me, tweet me, and I'll practice for the rest of the class. All right, take care. See y'all later.